Hello, my name is Balasubramaniam. Today I am going to present you my project titled Crop Yield Production. As you know, agriculture plays a crucial important role in global food security, and if we have to predict the crop yield productivity using manual ways, those will be expensive and time consuming. So with the advancement in satellite images and machine learning, we can now analyze the crop yield productivity using satellite images. So let me show you the working of my code. So as you can see, in this cell I have imported the necessary libraries needed for running our code. So .geo is used for using importing our library datasets everything, and rasterio library is used for reading our satellite images, and these are the necessary libraries I have used. So let me go to the dataset overview. I have used the dataset sustain bench crop yield productive dataset, and this dataset is mainly used for agriculture sustainability, used mainly using machine learning research areas. So this work doesn't contain real data satellite images. It contains already pre-processed histogram time series, which is extracted from the data real data satellite images. So what it does means it pre-process those spectral band in the satellite images. It extract them and it gives in a histogram time series format. As you can see, I will show you the shapes and everything according to this. So, and in this is mainly took from the satellite images in the regions of USA, Argentina, and Brazil. Only soybean crops are used in this one, and the target level is in tons per hectare. How much ton will be there per hectare area. So let me go to the how this data will look like. So here you can see the images shape are 9, 32, 32, and the first 9 indicates the number of spectral bands. There are 9 spectral bands, and you can see those 9 spectral bands are specified here. And the next 32 indicates the histogram bins. Histogram bins keeps the records of the number of pixel values in those bins. Like histogram value between 1 and 10 will be stored in the first bin. So like 32 bins will be there, and next 32 bins are the time steps. These time steps will be like our time period. A frame will be a particular frame will be captured for 32 different time periods. These time period done from April to October, which is a growing season for soybean, and this is the key concept. And now let's move on to model architecture. My model architecture mainly contains 3 components. The 3 components are CNN, LSTM, and attention mechanism. I have used CNN for capturing spatial information, feature extractions. It will capture the important features for our model prediction. So mainly CNN is used for spatial prediction, and LSTM is used for help the models in predicting the temporal features. It will help the model to predict how the frames or the data evolve over the time of period. Then attention mechanism. Attention mechanism helps the model to find the most important time period in the growth cycle. In the May, it may be the important season for our predicting crop yields. So attention mechanism will help in finding the most important time period. So then let's move on to, this is the code for our model architecture. As you can see, it contains the code for every architecture I have kept in. And next comes the training process. For this training process, I used 3 sets: training set, validation set, and training test set. Training set is mainly used for learning model parameters, and validation test is used for fine tuning the hyperparameters, and lastly test set is used for generalizing the models. So let me show you the configuration of my sets. As you can see, I have trained with 40 approaches and learning rate of 10 to the power minus 3, and weight decay, it is a parameter for regularization technique, which penalizes my model if it predicts gives a high level RME square. And I have seen for a batch 64 samples are used for a batch size, and these are the number of batches for training, validation, and test sets. Then you can see my performance metrics. and the best performance model is stored in my model. And I have got a R square of 0.71. It explains 71 variants of the model. Then I have got a root mean square error of 0.36. Then this saved model will be again trained on the it will be evaluating test sets, and the test sets gave results, and these are the final test sets results. You can see I have got again at R square of 71% and root mean square of 0.36. So this proves that my model is a good model. And next comes the loading images of the Iowa satellite. So this is a real satellite images I took from Earth Engine. So it contains the Iowa US state region of soybean from year 2024. So as you can see, I have extracted like around 26 frames for my model, and you can see there are 26 images, and I will show you the visualization. And this is the real visualization of the satellite image. And you can see this is a RGB frame, and the second one is a vegetation index. And this you can see the more green, the more crop, and this is a time period like April. From there it goes on to October time period. You can see like the more green, the more healthier, and if it comes to yellow color, so it is somewhat less healthy crops. So from using these, we will find our crop yield production and histogram reaction. So from those real satellite images, we will create our histogram time series frames. So this is the process for creating our histogram from satellite images. First, what it will do, it will first find our bands, the first dimension. As you can see, for each frame, it will predict the normalized difference vegetation index. So more the edge number, more healthier the crops it means. And lately, it will give us in our time series sample, and those time series will be given into our prediction model. And I got a prediction for this model output of 4.5 ton per hectare. So you can see average of 5 years is 3.61, and my model predicted the 4.5 for the year 2024, and I got a difference of 0.8 tons per hectare. So this is my model. So let me show you my web interface. So this is my web interface. Here you will upload your zip file which contains the time series of frames. It should be in a sorted order. It should be like from April to October. It shouldn't be merged. So then it will create a histogram time series according to those satellite images, and it will features there are a total of 26 frames, and remaining 6 frames will be padded. The last 6 frames will be padded. Also, as you can see, it's the same visualization, and it shows from frames. At 14th frame, I have got a peak of MDVI values, and again it's the prediction. So that's it. Thank you.